Vectors for two-dimensional motion. We've already learned scalars and vectors. Scalars are the quantities that can be completely defined using their magnitude only. For example, speed and distance. Vectors are the quantities that require magnitude and direction to describe them completely. For example, velocity. Any vector A can be represented by putting an arrow on it. Magnitude of the vector is represented by this, or you can simply just write the vector without the arrow sign. A vector whose magnitude is 1 is called a unit vector. It is represented as A cap equals to A bar upon A magnitude. For 3 dimension, starting from origin, unit vectors along x, y and z axis are denoted by I cap, j cap and k cap. Resolution of vectors. We need to resolve the vector into its components for the sake of simplicity. For any vector A making an angle theta along the x-axis and making an angle alpha with the y-axis, we have its components projected along x and y-axis. Let them be represented by the red lines. Let OC be the component along y-axis and OB be the component along x-axis. Let A be the length of vector A bar. Hence, in right angle triangle OAB, the value of OB will be A cos theta and the value of AB will be A sin theta. Similarly, in triangle OCA, the value of OC will be A cos alpha and the value of CA will be A sin alpha. So, this vector A can be simply represented in terms of its components as vector A equals to A cos theta I cap plus A sin theta j cap, or in terms of alpha, A bar will be equals to A sin alpha I cap plus A cos alpha j cap. The trick to remember resolution of vectors is simply remembering that the component adjacent to the angle subtended will always be cos component. Here, since vector A subtends an angle theta with the x-axis, the component OB is the cos component. Similarly, on the y-axis, the angle subtended is alpha, hence the adjacent component OC is A cos alpha. The other component will definitely be the sine component, hence here AB is A sin theta and AC will be A sin alpha. About addition of vectors, first we shall see polygon law of vector addition. For 4 vectors A, B, C and D, here the angle of the arrow represents their direction and the length represents their magnitude. So, for the polygon law of vector addition, the vectors are arranged from head to tail such that they form an open polygon and the resultant closing side will be the addition of all the vectors. Magnitude of the resultant vector can be found using the laws of trigonometry, and its inclination with the x-axis or y-axis can also be found in the same way. Now, if you have only 2 vectors, then the polygon law of vector addition becomes triangle law of vector addition. So, for any 2 vectors A and B, they are arranged such that they form 2 sides of a triangle. Then the resultant of these 2 vectors will be the third side of the triangle. The arrangement here is such that head of one vector is attached to the tail of another vector. If you arrange them differently, then we get our next law, that is the parallelogram law of vector addition. For any two vectors A and B, if they are arranged such that the tail of one vector is attached to the tail of another vector, keeping the angle between them constant, then they form a parallelogram whose diagonal gives the resultant addition of vectors A and B. To solve it mathematically, let us assume parallelogram ABDC. Dropping a perpendicular on extended AB, let us denote it by E. Then here the angle CAB, let us assume theta. Then DBE will also be theta because alternate angles are congruent. Let the angle made by the diagonal equals to alpha. By trigonometry, you can solve that BE will be B cos theta and DE will be B sin theta. Since DEB is a right angle, then in triangle ADE we have AD square equals to AE square, that will be AB plus BE the whole square, plus DE square. AB plus BE is nothing but A plus B cos theta, that will be the whole square, plus B sin theta the whole square. Simplifying it, we get A square plus 2AB cos theta. Here B square cos square theta plus B square sin square theta will give you nothing but B square. Hence, the magnitude of A plus B will be square root of A square plus 2AB cos theta plus B square. And the angle subtended by the resultant vector here alpha. So in the right angle triangle ADE, tan alpha will be DE upon AE, that will be B sin theta upon A plus B cos theta. Next is subtraction of vectors. To find the difference between any two vectors A and B, the direction of one of the vectors is reversed so that the resultant diagonal will give us the difference between A and B. Keep in mind that any quantity having a direction is not always a vector quantity. For example, electric current. Electric current has a direction, but it does not obey the laws of addition and subtraction of vectors. Hence, electric current is not a vector quantity. Resolution, addition and subtraction of vectors has important application in understanding the concepts of physics.